If I hold this bowling ball at some height, then we say that the ball has gravitational potential energy. And the reason we say that is because if I let go of that bowling ball, then gravity can do work on that ball. Now the question we want to try and answer in this video is exactly how much potential energy does this ball have? Meaning if I know the mass of this ball, let's say it's m, and I know exactly how high it is, what is the potential energy? That's what we want to try and figure out. All right, so how do we do this? I think we can do that if we understand exactly the meaning of this word. So what is the meaning of the word energy? Energy is the capacity to do work. It's a number which tells how much work you can do. So what will be gravitational potential energy? It is the capacity of gravity to do work. How much work gravity can do. So over here, if gravity can do, let's say 100 joules of work in moving that ball down, then we will say gravitational potential energy is 100 joules. If gravity can do only 2 joules of work, then we will say its potential energy is only 2 joules. Okay, so from this we can immediately say the gravitational potential energy by definition should equal how much work gravity can do on the ball. Gravity can do on the ball. Now before we begin, you may be wondering, why is it called potential? What is this meaning of potential? Well, in short, what it means is if I were to let go of this ball, then gravity will start pulling on it and that ball gains kinetic energy, right? It starts moving. So it's basically saying that the ball has the potential to gain kinetic energy. That's basic idea behind this. And of course, we have talked a lot about potential energies and kinetic energies in a previous video called energy. All right. So if you need more clarity on that, great idea to go back and watch that video. Okay, so let's calculate the work done on the ball. How do I calculate work? Well, in physics, work done is force acting on an object multiplied by the displacement of that object. So that means all we have to do is calculate how much force is acting on this ball multiplied by how much displacement this ball gets. All right, so how much force is acting on this ball? Which force are we talking about? Well, since we are dealing with gravity, we are talking about the gravitational force. And we have seen before, the force of gravity on any object is just mass times the gravitational acceleration, mg. We also call this as the weight of that ball. Okay, and how much displacement can this ball get? Well, if I just drop this ball, the ball will fall all the way from here to here. And so the displacement of that ball is just going to be the height. And so what do you think will happen if I multiply force and displacement? What will I get? Can we just pause the video and think about this? All right, we'll get force, which is the weight mg, times displacement, which is the height. And so this is the gravitational potential energy of the ball. It's m times g times h. Let's take some numbers. Let's say the mass of our bowling ball is 2 kilograms. And imagine we raise it to a height of, say, 3 meters. Can you calculate how much potential energy this ball will have? Go ahead, substitute and see how much you'll get. Okay, so if we substitute, we'll get mass, which is 2 kilograms. I'm not going to write the units. And the reason for that is because I already know the units of my potential energy. Since the energy is the same as work done, the unit of energy will be the same as work done, which is joules. And everything is in standard units, so our answer is going to be in joules. Okay, so I'll not put in the units. So 2 kilograms times g. How much is g? G is 9.8, but we can take it as 10. We can round it off. Times the height, which is 3 meters. And how much does that give us? That gives us 3 2s are 6. 6 times 10 is 60. So the potential energy of this ball is 60 joules. And what does that mean? This means that if I let go of this ball, then gravity will do 60 joules of work in pushing that ball or pulling that ball from here to here. Now, before we wrap up this video, one doubt I always had is, should I calculate this height always from the ground itself? Here's what I mean. Imagine I'm holding a bowling ball on the first floor of a building. Now to calculate the potential energy over here, should I calculate the height from the floor of that room? Or should I calculate the height from the ground floor of that building? Which height should I take? What do you think? This was my biggest confusion. Well, you can take any height you want. It all depends upon the situation. For example, if you're dropping this ball on the first floor, then it'll go and hit the floor over here. This is the lowest point, right? So this is kind of the ground for us. In that case, it just makes sense to say that this is the height. And so we'll get a smaller value of potential energy. And that means gravity can only do work from here to here. So less potential energy. On the other hand, if you were to take that ball and throw it outside the balcony, first of all, you should never throw a bowling ball outside the balcony, but let's say you did. Now, that ball can fall all the way down to the ground. So now it makes sense to say, this is the height of that ball. And so you'll get a larger potential energy for that same position, because now gravity can do more work from here all the way till here. So yeah, your potential energy completely depends upon what you choose as your ground, and you're free to choose whichever level you want as your ground. And what I like to do is, whenever I'm calculating potential energy of any object, I will take the lowest point that object can go as my ground and calculate the height from there. So if I'm dropping the ball on the first floor itself, then to calculate the potential energy of the ball over here, I would just take this as the height. And just to give you another example, let's say we're dealing with a pendulum. Imagine that bob is attached to a string and we can make it swing. And now if I want to know what is the potential energy of the ball over here, again, I will think what is the lowest point that ball can come in this experiment. So here, if I let go of the ball, notice the ball can swing to this. This is the lowest point the ball can come. After that, the ball will go up there, right? So in this case, it'll just make sense to say this as our ground level and this as the height to calculate the potential energy of the ball at this point. So to summarize, what did we learn in this video? We learned how to calculate the potential energy of any body due to gravity. And how do we do that? Well, we calculate how much work gravity can do. And just like any work, we multiply force into displacement. The force over here is the force of gravity, and the displacement will just be the height, giving us mgh. Which means if you ever forget this equation, no problem. If you just go back to the basics of work done, you can always derive it in one step. And if you ever get confused about from where should you calculate that height, where is your ground in general, then you are free to choose whichever level as you want as your ground. And what I like to do is that in any experiment, I ask myself, what is the lowest point that object can reach in that experiment, and then call that as my ground and calculate the height from there to calculate potential energy.